This is kind of the beginning. This is like chapter one for assignment one. You'll read a little bit about the soils around us and kind of get an understanding of some of the basic things uh, that you kind of need to understand when we're talking about soils. And so, if you were in my actual physical class, one of the first things that I would tell you is not to call it dirt. It is not dirt. And if you say that around soil scientists or around me, you can see my face change. And I will try to try to kind of keep that in. But dirt is like what's underneath your fingernails. It is kind of what's on the bottom of your shoes. Maybe if you track it in the house, probably something that you sweep up, or maybe like a dirt road. And in most of those places, if you think about it, there's not very many plants that are growing there. And so the Soil Science Society of America sat down and they came up with this big kind of all inclusive uh, definition of soil being this unconsolidated mineral or organic material on the immediate surface of the earth that serves as a natural medium for the growth of land plants. And I believe that this is probably the biggest part, natural medium for the growth of land plants. And that to me is what separates the difference between dirt and soil. Soil is something that you grow things in, dirt is misplaced soil. So when we're thinking about this ideal soil, and you heard it in the previous slide about the definition, is going to be that unconsolidated mineral and organic matter. So we have 45% mineral space, and that's going to be like the actual physical part of that soil that you can actually feel and touch, right? Next, we have about 5% organic matter. It's probably about the max that you can get is 5%. We have 20 to 30% water and then 20 to 30% air. And so on the left side of this pie chart, you'll see that fluctuation in between air and water because what happens when it rains a whole lot? Let's say you get 1 inch of rain in an hour. And if all that water went into the soil, how much airspace would you actually have? Wouldn't have much, right? Because most of those pore spaces are filled with water. Okay, so same situation. We have 1 inch of rain per in an hour, whatever went into the soil went in, and then let's say we didn't get rain for another week and a half. Now, which side of that graph do you think would have the larger portion of that? It would be mostly filled with airspace, right? Because most of that water would either be drained out or it would be used up by the plant. And so then there wouldn't be any water in the soil. So that's going to fluctuate. The mineral composition of that soil is not going to fluctuate very much. It might change a little bit, 43 to 48, depending on how much organic material you have. Also, the bulk density. But for the most part, the mineral that's there is the mineral that's there. It's not going to fluctuate much. We can influence the organic matter and we can influence the pore space, but we can't really change that mineral space. Okay, so moving into kind of these principles of regenerative agriculture, and as I mentioned before, I'm not too super like hardcore regenerative ag. We've got to regenerate our soils. I believe that if we kind of use the right approach, we will not degrade our soils faster than they can be regenerated. So, one of the first things is you need to understand the context of your farming operation. Like, what are you trying to grow? What is the management? Are you going to be intensively managing this field? Is this going to be something where you're not going to do a lot of tillage? What are your goals of your operation? So, first off, is understanding the context of your farming operation from planting all the way to harvest, and then what you're going to do in the fallow season, like in the winter time, possibly, is going to help you understand what you need to do in order to minimize your soil loss. The next thing is minimizing that soil disturbance. So, if soils are not tilled and they're held together, there are some benefits, such as We can increase the organic matter because we're not turning that soil and exposing it to oxygen. We increase the habitat for those microorganisms that are helping us uh, recycle our plant material. You're getting better soil structure. You're getting better aggregation, and better aggregation leads to, again, that better structure, but you're also not going to lose a lot to runoff. We're getting better infiltration. We're getting better percolation. So infiltration is the movement into the soil. Percolation is the movement and the distribution through the soil. So that tillage is going to help keep or minimizing that tillage is going to help keep our soil on our property. Next, you want to maximize this crop diversity. One of the problems that we have is that we will grow a continuous crop, such as corn. And eventually, corn will deplete all the nutrients, some specific nutrients, and we have to replenish those. So, something that we might do is grow corn one year and then soybean the next year so that we can kind of put some nitrogen back into the soil and we don't have to supplement that with fertility. Also, that crop diversity is going to have an impact on insect populations, disease populations. It's going to be an opportunity for insects like bees or butterflies or any of these pollinator species to be able to move in. There's just a multitude of plants that they can move it to and from. Next, we want to keep the soil covered. Like for me, this is the big one. Always have something growing on top of your soil. Bare soil will leave you no soil because there's nothing to hold that soil in place. And if we do get that 1 inch in 1 hour, most of that is going to go into the creek. And now your soil is not on your property. You've put a lot of nutrients on that soil, and those are now in the creek now. And now you have to put more money on there. So for me, one of the biggest things is to keep that soil covered with a cover crop. And with that, we maintain this living root all year around. And those roots are also going to help keep that soil in place. So we're going to minimize this soil disturbance. We don't want to till because we're trying to improve our aggregation. We want to keep that soil covered so that we have something to kind of soften the blow of any of those raindrops, minimize this erosion, but also this keeping this root year round has other benefits, such as holding that soil stable. Some of those exudates that come out of that root are going to be useful for microbial populations. And then also, if that, once that root dies, that is also going to be some carbonaceous material for those microorganisms. So these kind of three things right here are going to be key for this regenerative agriculture. And then finally, the last one is just because it's part of the whole principle. This whole umbrella of regenerative ag is integrating livestock. And I've talked with Dr. Fennewald about this, a colleague of mine, and he has mentioned that you can do all of these things, but it appears that integrating this livestock is uh, a very key component to that. And so for me, I'm mostly row crop, so I just wouldn't think about opening up a field and letting a bunch of cows run wild in there and just doing whatever they're going to do. This integrating the livestock is mostly going to be for our hay grounds and making sure that we can regenerate those soils. So you can do all of this stuff, and most of us are not going to till our hay field, and we have something growing on it all year, so it's always covered, and we always have that living root. But we're still losing some soil. We're not regenerating it fast enough. And so Dr. Fennewald believes that it is this integration of that livestock that is really kind of the foundation, or I guess maybe not the foundation because these are the foundation. It's going to be the extra on top of it that regenerates that soil. All right, so just kind of going back through that, we want to understand the context. We're going to minimize that disturbance, maximize our crop diversity, and we're going to keep that soil covered by maintaining living root year round. And we're going to try to integrate some livestock where it makes sense. So for me, soil is the foundation of nutrition. It's where we get all of our nutrients from. It is where we have these soil biology, the bacteria and the fungi. It's where they live that kind of do this nutrient cycling. The more the nutrients are cycled, the greater the uptake of the plant. There's this whole soil, air, plant continuum that we are looking to kind of optimize the balance between so that we can maximize our nutrient uptake, because that's where humans and animals get most of their nutrients from, is going to be in the plant. So that's why it's important for me, this whole soil concept that we are using soil to grow plants to feed people. And we're going to talk, and we kind of talked about most of these just here in this last slide. We want to increase that organic matter. We're going to keep that covered, and we want to kind of use crop rotation in order to kind of not be so boring and kind of deplete our soils. So in the area of soils, we have two different kind of areas of study that we're looking at. We have pedology, and that pedology is really going to be more of kind of module 1.3. That's going to be like, how did the soil form? How do we classify this soil? Having a better understanding of what that soil um, is going to be kind of the basis and the foundation, because we can use some of this information to kind of determine whether or not we can or cannot grow a crop. So for, this is going to kind of be module 1.3, but overall, kind of for me, this is going to be this edaphology, where this is the study of the soil's influence on living things. So that's the influence on microbes. That's the influence on earthworms and beetles and grubs and things that grow in there. The influence on plant growth, and ultimately the influence on humans, because soils is really kind of, if we didn't have soil, we wouldn't exist. So we have pedology, which is going to be kind of the looking at soil formation, and then we have edaphology, which is going to be looking at how that influences living things. So soils are going to ultimately determine the ecosystem. We can see the difference in, let's say, uh, you know, the Amazon rainforest. And if you can think about the rainforest having this, there are multiple tree species, multiple plant species, multiple insect species, all growing. And the soil types there are more conducive for plant growth than they would be, let's say, in the Sahara Desert, where there are not a lot of trees, there are not a lot of plants, there's not a lot of microbial populations. So, where that soil is, that the different soil types, we can even look at it in the United States, that the soils in Tennessee are much different than the soils in Colorado, or even California, or even Texas, or Arizona. Going to be much different than soils that are in Michigan, and we have Indiana and Ohio, Illinois. As we move up in here, we're looking at Minnesota and South Dakota, kind of the Great Plains states, Nebraska and uh, Kansas, all different soil types and all different crops and cropping systems are grown in each one of these. Naturally, it influences our food supply, from fruits and vegetables to crops to corn to soybeans. Some of the things that we feed our animals. And so, some people might not know that the majority of the corn grown in the United States is mostly to feed animals and concentrated animal feeding operations. Our fibers is where we get our wood from. We're uh, kind of roundabout the wool. So sheep are eating the plants, and sheep give us wool. Obviously, cotton and trees for paper. Fuel, wood burning stoves. Actually, coal is part of soil. So we are digging that coal out of the ground that has been compacted over eons, millions of years. We're using corn for ethanol. Some of the big functions of soils that we're going to need in our daily lives is we can use it as a recycling system. And so we have this growth and then we have this decay. That is how we increase our organic matter. It can modify the atmosphere. So there's a lot of that soil air continuum and plant continuum where soil influences kind of what happens in the atmosphere. That as heat rises or water rises from the soil, we get these rain clouds. We can grow plants that influence the carbon dioxide concentration. It's a habitat for organisms. We use it as an engineering medium. Um, I will concede that you could probably call, let's say, if you've ever seen them building a highway, that red clay that they're using, I would not be too far off if someone used that for dirt, because like that is dirt work or earth work, possibly. We can use it to purify our water supply. But ultimately, for this class, we're going to use it as this medium for plant growth, as I mentioned in that very first slide. As a recycling system, we have the hydrologic cycle and all of these different nutrient cycles this is going to be kind of module 3, and these are going to be kind of in module 4. So for modifying the atmosphere, when we talk about the atmosphere, it also influences the biosphere, the hydrosphere, and then finally the lithosphere. And so the way that soil interacts with these different spheres, and then each one of these different spheres interacts with another, that's kind of why I consider soils to be so very important. So we got the atmosphere, we got the biosphere, which is this living with these are the living things. We have the hydrosphere and then the lithosphere. And so if we look at this, we can kind of see that this is, if we go back to that pie chart, this is the mineral matter. This is going to be this organic material, that 5% organic. Here's the hydrosphere and the atmosphere being the water and the air. All of these organisms that exist within our soil they all play a role for some reason or another. We might not understand or know all of those, like particularly ants. But ultimately, what these organisms do is they decompose this material. That is kind of their ultimate goal. They are the decomposers of the soil. As an engineering for medium, we're building the houses with this. They had different houses, different structures that they're growing with soil because they just can't make concrete. And if you get the right type of clay material, then you can make this into, I think, what they call an adobe. Look, they used the wrong type of soil for this. And so they put this blacktop over a soil that did not have good structure or aggregate stability, and it separated, and now we have a problem. Water supply and purification. The water cycle, we are going to have evaporation, precipitation, that is going to add that water back. As that water moves through the soil profile, there are charges on the soil that remove some of those pollutants and ultimately basically act like a big brittle water filter. So we have these different layers. So we have an O for organic. This is going to be the top portion of that layer. We'll go over this again when we talk about formation. We'll have the surface layers, we have the subsoil, the substratum, and the bedrock. So OA, B, and C. And then in classification within each one of these, there are different meanings for that. Not so much important for this 2000 level class, but if you were to take soil classification, then you would get more in depth with that. So as I mentioned, we're going to be studying mostly about this medium for plant growth. So one of the things that soils or 4 things that soils provide as a medium for plant growth are going to be support or anchorage. This is where the roots grow. And once the roots grow, then they can then support that plant life. Next, they provide air. so that the exchange between oxygen and carbon dioxide as movement in and out of that soil is going to have an impact on that plant growth. We have water, so that is going to provide water for that soil, for that plant. If we have a soil that can hold on to a lot of water, then we can expect to have a more sustainable plant life or a more sustainable growing season. If you want to think about this, think about the difference between having a silt loam soil or at a beach or maybe a clay. Which one do you think is going to hold on to more water? A clay or a sand? Clay, right? Because I mean, many of us have been to the beach. When that water will move through a sandy soil a lot faster than it will move through a clay soil. And ultimately, it's going to provide these nutrients. And so, the 18 essential plant nutrients, that we have a mnemonic for that, and that mnemonic is C. Hopkins Cafe, managed by my cousin Mokel Nina. C. Hopkins Cafe, managed by my cousin Mokel Nina. And these all come from the periodic table. And so we have these different macro and micronutrients. So for our macronutrients, you will need to know the full elemental name, but you do not need to be too concerned with the plant available form. Some of these you might be familiar with, but on the exam and the quiz, I will only ask you to separate between macro and micronutrients and give me the full elemental name. So we have carbon, hydrogen, and oxygen. We're getting most of these from either the air or water. Next, we have phosphorus. K for potassium. And nitrogen. And so on a fertilizer bag, these are going to be the three elements that we use the most of. Like these are the three very important elements for plant growth. So we have carbon, hydrogen, oxygen. We have phosphorus, potassium, and nitrogen. And sulfur, calcium, and magnesium. So for the first part, we have C. Hopkins Cafe. So carbon, hydrogen, oxygen, phosphorus, potassium, nitrogen, sulfur, calcium, and then magnesium. Next, on the micronutrient side, we have iron, boron, manganese, copper, zinc, molybdenum, molybdenum, molybdenum. And then finally, chlorine, nickel, and sodium. There are likely to be some other micronutrients that someone somewhere found that if you add maybe cobalt to a soil and you supply that there's some slight influence on plant growth. But most of the time, I mean, here we have salt, and I don't think salts are good for plants, but these are used in, very small amounts. So the macronutrients are typically going to be in pounds per acre, and our micronutrients are typically going to be in parts per million. And so a very small amount of these nutrients are needed. And these these are important in a lot of the metabolic functions. Uh, maybe some enzyme production or protein production. All right. So that is going to be the end of this module 1.1. Apologize for the phone call. Should have put my phone on silent. But that is the end of that. So you'll probably like to have to see this again. One of the things that I probably didn't mention in the beginning of the video that will probably help you is that if you wrote something down, if there was a blank that you had to fill in, that is likely where I'm going to pull a test question from. Right? Like those are the key points that I would like for you to kind of focus on and have a better understanding of. So as you're going through, like, man, if you didn't write it down, I probably didn't think that it was a very important thing for you to like be studying and memorizing. But if you wrote it down, there's probably a pretty good chance you're going to see that again on an exam or a quiz. Okay, that is going to do it for this video. I will see you in the next one.